Good morning to all. We see about the implementation of k-means clustering for customer segmentation. This is the code for implementation of k-means clustering. Step A, to write a program to implement the k-means clustering for customer segmentation. We will do customer segmentation with a Python code. Equipment method of PC cell Anaconda Python 3.7 installation, and also this is a repeated notebook. It will better for compare. Algorithm that is used where import pandas library and matplotlib library files, read the dataset and transform it. And thirdly, import k-means and fit the data in the model. Plot the cluster graph. Next program, which is a program definition. In first line of the program, this program will change that implementation of k-means clustering for customer segmentation. In first line of program, let's say we will import pandas library as PD and matplotlib library file as CLT from sklearn.customer import k-means clustering observer. Pandas library for handling and analyzing structured data. Matplotlib.pyplot used for data visualization. Scalar.cluster.k-means is used for implementing k-means clustering. Next, we load the dataset. Next, we load the dataset. Data is equal to pd.read.csv small customers. Small customers is already uploaded in this repeated notebook and used to the pd read csv file. This will be read by pandas file and it is stored in data. Load the CSV file into the pandas data frame. Replace the file path with the actual file location. Display dataset information. These are the print data.head, print data.info, print data.additional.sum. Data.head is used to displace the first 5 rows of the dataset. Data.info provides a summary of the dataset, including data type and non-null counts. Data.additional.sum checks for missing values in each column. Next, you open a empty list called VCSS. Next, we use the for loop for I in ranges from 1 to 10. K-means is equal to k-means k-means function of n cluster is equal to I init k-means cluster random state is equal to 42. VCSS what for stores the sum of square distance between the data points and the cluster centroids for each n clusters. Next, for loop for I in range 1 to 11 iterates to cluster counts from 1 to 10. K means n cluster of I is equal to cluster of I. Initialize k means with I clusters. Next, unit is equal to k means I is used for improves the centroid initialization process to speed up convergence. Random state is equal to 42. Ensures reproducibility of results. Next, k means dot fit function of data dot ilog of 3 just in the columns of three values taken by the interpreter. Select the columns annual income and spending scores for clustering. The two only taken by the interpreter. Next, add VSS list by append method k-means.inertia. K-means inertia is used to measure the VCSS for current cluster configuration and appends it to VCSS list. Next, plot the elbow graph. We plot the graph by the matplotlib pyplot library as we already used PLT as it. So we use plt.figure. Figure function is used to figure out the model. Pig size equal to 8 to 6. Into 8 to 6. 8 comma 6 is the value which we plot the point and create a plot with the specified dimensions. plt.plot ranges from 1 to 11. Next VCSS marker is equal to 0. Plots VCS against the number of clusters. Next, the elbow in the graph indicates the optimal number of clusters. Next, we plot X label, Y label, title, as we know already about that. Next, plot dot show. Km is equal to K means n cluster is equal to 5. Init is equal to K means plus random set is equal to 42. Already we expressed in this program that we already used K means. This also used K means. Km is equal to K means n cluster is equal to 5. That means K, K means n cluster is equal to 5 specifies 5 cluster based on the elbow method. Next, km.fit the models to the selected columns. Km.predict predicts clustered labels for each data point. Next, random state is a y predict use that the km.predict data iloc of three variables, three columns contains a predicted cluster label for data point. Next, add cluster labels to the dataset. Data clusters is equal to y predict. Data clusters equal to y predict creates a new column cluster in the data frames to store the predicted cluster labels. Next is separate data B clusters. PFO is equal to PF0 is equal to data. Already we have data. So data cluster is equal to 0. We assign a value. Start that figure. Let's figure that filters the data, separate database clusters, or this separates the database clusters, filters the data for each cluster 0 to 4 into separate data frames. Next, we visualize the clusters by plt.figure. The trigger size will be 10, 7. Plot of scatter df of 0. It already knows that it will give the physical red color. In red color, it will give points and label is equal to cluster. It will give label as a cluster of 0. This figure plots gives a creates a scatter plot for each cluster, color coded for distinction. It gives a color coded for the distinctions. X-axis annual income. X-axis based on the annual income. Y-axis based on the spending scores 1 to 100. We already know about that. Add clusters in centroids. First, centroids is equal to km dot cluster differences, which is the function. Plot dot scatter. Centroids is equal to the yellow columns of 0. Centroids with columns of 0 is equal to 300. C is equal to yellow mark. The yellow at the mark of marker is equal to label centroids. This will go given in this centroid. All stars are called centroids. This will write by this function. Next, we will use to retrieves the coordinates of the centroids. This function is used to retrieve the coordinates of the centroids, which will be used as a star marker. Star, we see that yellow color. Next, plot the centroid as yellow stars or better visualization. Final plot customization. We will finally customize the plot by plot.legend. Plot doesn't add a legends into identify clusters as centroids and centroids. Plot.x label. X label we use annual income, Y label we use spending scores 1 to 100. Title we use first estimate and it will source program. This code cluster customers based on the annual income and spending source and visualizes the results. You'll see that this will be the 5 data that will be given by these ones. Print data set info, print data dot sum. These 5 data are printed by that. Next it will give that for loop and it will give this and we will plot the figure by the number of clusters we use LO method and 1 to 11 range from 1 to 11. We put this number of clusters LO method basis by this. Next we print this array by this number of array by this. These functions are km dot fit km dot fit. Y predict is equal to print Y predict. These all variables are stored in an array and are stored in a list and it will give output. Next we will finally plot the points. This will this will work. These are the points which is surrounded by the yellow mark. This yellow mark is centroid for each of the colors. You'll notice that all are in centroid of the clusters. Okay, thank you. We'll